Tonight, before we begin, I want you to do something for me. Go outside, if you can, or just look out your window. Find the darkest patch of sky you can see. Now, somewhere out there, beyond what your eyes can detect, beyond what any telescope currently pointed at that patch of sky could see. Something is moving. It has no light, no star to orbit, no sun to illuminate it. It is just a world, a planet, possibly the size of Jupiter, possibly the size of Earth, possibly something in between. A completely dark, moving through interstellar space at tens of thousands of kilometers per hour, completely alone. And we would have no idea it was coming, not until it was already close. We call them rogue planets, free-floating planets, worlds without stars. And in January 2026, just weeks ago, scientists achieved something that had never been done before in the entire history of astronomy. For the first time, they measured the mass of one. They confirmed its distance. They proved, beyond doubt, that it is a real planet, not a failed star, not a brown dwarf, not a measurement error. A genuine world, approximately 1/5 the mass of Jupiter, floating completely alone in the darkness of the Milky Way, 10,000 light-years from Earth. The lead researcher at Peking University said it plainly. For the first time, we know for sure it is a planet. And our discovery offers further evidence that the galaxy may be teeming with rogue planets. Teeming. That word was chosen carefully. Because here is what scientists currently believe about the number of rogue planets in our galaxy alone. The conservative estimate is billions, not millions, billions. Some models suggest the number could be in the trillions. There may be more rogue planets wandering the Milky Way right now than there are stars in it. More homeless worlds than suns to orbit. The galaxy, it turns out, is not a collection of star systems separated by empty space. It is a collection of star systems separated by an ocean of dark, invisible, wandering worlds that we are only now beginning to discover. And we can barely see any of them. That is the thing about rogue planets that keeps astronomers up at night. Not the romantic version of lying awake staring at the stars, but the other kind. The kind where you run the numbers again, because the first answer cannot possibly be right, except that it is. We detect rogue planets almost entirely by accident, by watching a background star flicker for a few hours as a dark, invisible planet passes in front of it and bends its light. A gravitational shadow, a ghost. The event lasts between a few hours and a few days. There is no second chance to observe it. And if you were not pointing your telescope at exactly the right patch of sky, at exactly the right moment, the planet passed through, and you never knew it was there. That is how we have been trying to count objects that may outnumber stars. A few hours, then gone. Tonight, we are going to go deep into this subject, deeper than almost any video has gone before. We are going to understand exactly what rogue planets are, where they come from, and how they form. We are going to meet the specific ones scientists have found and ask what they have taught us. We are going to sit with the question that no one quite wants to ask out loud: whether one of these invisible worlds has ever passed through our own solar system, or could in the future. And we are going to understand why the answer to that question is far stranger and more interesting than a simple yes or no. But before any of that, I want to stay with something for another moment, because I think it deserves more than a single sentence. A planet without a sun. Think about what that actually means. Every planet you have ever seen, every photograph from Voyager, from Cassini, and from the James Webb Space Telescope, every world that has ever appeared in a textbook or a documentary or a school science fair project. Every single one of them exists in relationship to a star. They are defined by their orbits. Their seasons are determined by their distance from a sun. Their atmospheres are shaped by the light and radiation they receive. Their temperatures, from the volcanic infernos of Io to the frozen deserts of Pluto, exist on a spectrum anchored at one end by the heat of a star. Take away the star. Kick the planet out into interstellar space. Now what? Now you have something that has no day, no seasons, no sunrise and no sunset ever for billions of years. The sky is pure black in every direction. The nearest star is light years away and contributes almost nothing to the surface temperature. The planet is heated only by its own internal geology, by the radioactive decay of elements in its core, by the residual warmth of formation that bleeds away slowly over billions of years. And depending on its size, depending on its composition, depending on how long it has been traveling, the surface of a rogue planet could be anything from a frozen wasteland at 200 degrees below zero to a surprisingly warm world with liquid water. Liquid water on a planet with no sun. In the complete darkness between stars. That is not speculation. That is physics. Small rogue planets with thick hydrogen atmospheres can retain enough internal heat to maintain liquid water on their surfaces for billions of years. There may be rogue planets in the galaxy right now, dark, invisible, completely alone, with oceans, possibly with the conditions necessary for life, floating through the permanent night between the stars with no one around to know they are there. That idea is either the most beautiful thing in astronomy or the most terrifying, and I have never been able to decide which. Welcome to Science for Sleep, the place where the biggest mysteries in the universe become the last thing on your mind before you drift off. Tonight, we are going to talk about the worlds that belong to no star. The planets that were thrown out, cast off, ejected from their homes at the very moment of their birth, and have been traveling through the darkness ever since. Rogue planets. And by the time we are done, I promise you we'll never look at the night sky the same way again, because you will know with absolute certainty that what you cannot see out there is vastly more interesting than what you can. Before we go any further, if this kind of content is something you value, if spending a quiet evening understanding something truly extraordinary about the universe feels like exactly what tonight needed, please consider hitting like and subscribing to Science for Sleep. We are a small channel. Every single subscriber genuinely matters to us. It takes 2 seconds, and it is the single most important thing you can do to help us keep making this kind of content. Thank you. From the bottom of our hearts. Thank you. Now, let us begin at the beginning. Not with rogue planets as they exist today. Dark, invisible, traveling alone through the galaxy. But with the catastrophic moment when they are created. The moment a planet is born and then immediately torn away from everything it will ever know. Every rogue planet has a story, and almost every story begins the same way. Not with darkness and loneliness, but with warmth. With a young star newly formed, surrounded by a spinning disk of gas and dust. With a slow, a patient accumulation of matter into worlds. With a solar system being born. To understand how a planet ends up alone in the dark between the stars, you first have to understand how normal planet formation works. And the answer is that it is not, as it might appear from the outside, a gentle or orderly process. It is violent. It is chaotic. It is a game of gravitational billiards played with objects the mass of entire worlds, at speeds and timescales that have no human equivalent. And most of the time, the game produces losers. Here is how it works. Around a newly formed star, there is a protoplanetary disk, a rotating pancake of gas, ice and dust that extends outward for hundreds of millions of kilometers. Within this disk, solid particles collide and stick together. Small grains become pebbles. Pebbles become boulders. Boulders become planetesimals, objects tens or hundreds of kilometers across. Planetesimals collide and merge into protoplanets. Protoplanets eventually accumulate enough mass to become planets. The whole process, from dust grain to finished planet, takes somewhere between a few million and 100 million years. On cosmic timescales, that is almost nothing. On human timescales, it is incomprehensible. But here is what the textbook version of this process leaves out. The disk does not form just 1 or 2 planets. It forms many. In the early solar system, my models suggest there were not 8 planets, but perhaps 15 or 20. Protoplanets and large planetary embryos jostling for position, their orbits overlapping and interacting, their gravitational fields pulling and pushing at each other in an increasingly crowded gravitational arena. And not all of them could survive. The ones that did survive are the 8 planets we have today. The ones that did not. Some were absorbed by larger neighbors, some were broken apart in collisions, and some were ejected. Ejected. That word does not quite capture the violence of what actually happens. Imagine a planet, a world perhaps the size of Earth or larger, with its own geology, its own interior heat, possibly its own atmosphere, being flung out of its solar system by a gravitational interaction with a larger neighbor. The mechanism is called planetary scattering. When two planets approach each other closely, their mutual gravitational attraction can dramatically alter each other's orbits. If the interaction is powerful enough, if one planet swings past another at the right angle and the right distance, the smaller one can receive what is called a gravitational kick, a sudden, enormous transfer of energy that accelerates it far beyond the escape velocity of the parent star. The planet does not gradually drift away. It is hurled outward. In astronomical terms, it is gone almost instantly. It crosses the outer boundary of the solar system, passes beyond the influence of its star's gravity, and enters interstellar space, alone, forever. How often does this happen? This is where the numbers become genuinely staggering. Computer simulations of young planetary systems consistently show that ejection events are not rare exceptions. They are routine. Some models suggest that most planetary systems eject at least one planet during their first few 100 million years. If either of these estimates is anywhere close to correct, and there are several 100 billion stars in the Milky Way, then the total number of rogue planets produced through ejection alone across the history of our galaxy is in the hundreds of billions at minimum, possibly in the trillions. But ejection from a planetary system is only one way a rogue planet can be born. There is a second pathway, stranger, more direct, and more philosophically troubling, that has nothing to do with star systems at all. Some rogue planets may never have had a star. They may have formed the same way stars form, from the direct gravitational collapse of a cloud of gas and dust in interstellar space, but without enough mass to ignite nuclear fusion and become a star. They condensed out of a molecular cloud, contracted under their own gravity, heated up in their cores, and stopped. Not enough mass, not enough pressure. The nuclear fires never lit. What was left was a planet-sized object, a world, that formed in total isolation, without a disk, without a solar system, without companions of any kind. It has been dark and alone since the moment of its creation. In 2025, a team of astronomers was using the James Webb Space Telescope to study a population of rogue planets in a nearby star-forming region. They found 8 of them, massive, Jupiter-sized objects drifting alone in space. And 6 of the 8 had something orbiting them. Disks, protoplanetary disks of gas and dust surrounding rogue planets that had no star of their own. Worlds that are forming worlds. The lead researcher put it carefully but unmistakably. The building blocks for forming planets can be found even around objects drifting alone in space. Think about what this means. A rogue planet thrown out of its solar system or formed in isolation, can acquire its own disk of material and begin forming smaller planets around itself. A micro-solar system built around a world that has no sun, floating through the interstellar void, completely dark, with its own collection of forming worlds in orbit. A family of planets that will never see starlight. 3 pathways in total. Ejection through gravitational scattering. Direct collapse in isolation. Disk fragmentation in binary systems. 3 completely different origins. 3 completely different histories, all producing the same result. A planet, alone, in the dark, moving through the galaxy on a trajectory determined entirely by the chaotic mechanics of its birth. There is one more thing about rogue planet birth that deserves a moment before we move forward. It concerns the planets that were almost us. The early solar system was not stable. In the first few 100 million years after the Sun formed, the giant planets were migrating. Their orbits were shifting. Jupiter, in particular, moved significantly inward before being pulled back out by Saturn's gravitational influence. During this period, models consistently suggest that at least one large body, possibly several, was ejected from our solar system, thrown out by Jupiter, gone. Those ejected worlds are out there somewhere, former members of our solar system, planets that formed from the same material as Earth, from the same disk of gas and dust that built everything we call home. They grew up alongside Mars and Venus and Earth, orbiting the same young sun. And then Jupiter's gravity flung them out. They have been drifting through the galaxy ever since, for 4.5 billion years, moving away from the sun at speeds we cannot currently track. We do not know where they are. We cannot see them. We will almost certainly never find them. Our lost siblings, the planets that could have been neighbors, rolling through the same night sky we see from Earth, but instead became rogue planets, dark, cold, alone, the moment Jupiter decided they were in the way. The galaxy is full of stories like this. Every rogue planet is one, and we are only just beginning to read them. Imagine you are sitting in a completely dark room. No lights anywhere, and somewhere in that darkness, someone is moving, quietly, without making a sound. You cannot see them. You cannot hear them. You have no instrument that can detect body heat or movement. The room is silent and completely black, but there is one candle on the far wall, a single, tiny, steady flame. And for a few seconds, just a few, the flame appears to grow brighter. Not because the candle changed, but because something passed in front of it. Something between you and the candle, invisible in the darkness, bent the light of that flame ever so slightly toward your eyes as it crossed the line of sight. And in that brief brightening, that quiet, almost imperceptible swelling of light, you know, something was there, something passed. That is gravitational microlensing. That is how we find rogue planets. And it is without question, one of the most elegant and improbable detection methods in the history of science. The candle in the analogy is a distant star, a star thousands of light years away, near the center of the Milky Way, burning steadily and unremarkably for millions of years. Between that star and our telescopes here on Earth, there is a vast corridor of space. Almost always that corridor is empty. The star shines. We record its brightness. Nothing changes. But occasionally, rarely, unpredictably, with no advance warning, a rogue planet drifts into that corridor, moving silently on its interstellar trajectory, completely dark, completely invisible. It crosses in front of the distant star, and for a few hours, sometimes just 2 or 3, sometimes up to a few days, the star appears to brighten. Not because the star changed, because the rogue planet's gravity is bending the star's light, acting like a cosmic lens, focusing photons toward our telescopes. A gravitational shadow that reveals itself as a flash of light. The effect lasts only as long as the alignment holds. The rogue planet keeps moving. The alignment breaks. The star returns to its normal brightness, and the only record that anything happened at all is a light curve, a graph of stellar brightness over time, showing a brief, characteristic rise and fall, a bell-shaped pulse of extra light lasting a few hours and then gone. The rogue planet does not know we were watching. It does not slow down. It does not linger. It simply moves on, back into the darkness it came from, taking all its secrets with it. On the morning of May 3rd, 2024, a routine monitoring event was recorded simultaneously by 2 separate telescope networks. The Korean Microlensing Telescope Network, 3 identical telescopes on 3 different continents, and the Oumuamua telescope in the Atacama Desert, both recorded a brightening event in a background star. The brightening was brief, consistent with a low-mass object, planet-sized. What made this event unlike any before? It was what happened next. The Gaia Space Observatory, positioned 1.5 million kilometers from Earth, also recorded the same brightening event. But it recorded it approximately 1 hour and 53 minutes later than the ground-based telescopes. 1 hour and 53 minutes. That delay is everything. Because Gaia was observing from a slightly different position in space, the alignment between Gaia and the rogue planet and the background star peaked at a slightly different moment. This is called microlensing parallax, and it is the key that unlocks the fundamental problem that had stymied every previous detection, the mass-distance degeneracy. With 2 observations from 2 different positions in space, Professor Subo Dong's team at Peking University could finally solve both unknowns simultaneously. The object was located approximately 10,000 light-years from Earth. Its mass was approximately 22% of Jupiter's mass, roughly the mass of Saturn. A genuine planetary mass object, a planet. The paper was published on January 1st, 2026. The lead author chose one word that stands apart from everything else in the publication: teeming. The galaxy may be teeming with rogue planets, not scattered, not distributed, teeming. For the first time in history, backed by a directly measured planetary mass. We watched it for 10 days. We will never see it again. That is the strange intimacy of microlensing astronomy. Every detection is a one-time encounter. You get one look, lasting hours or days, and then it is over. There is no follow-up observation. The planet has moved on. All that remains is the light curve, a brief graph with a small bell-shaped peak in the middle, and the knowledge that something passed and we were watching. The era of one detection at a time is ending. The Nancy Grace Roman Space Telescope, named for NASA's first chief of astronomy, will stare at the galactic bulge continuously and detecting microlensing events at a rate 1,000 times greater than Hubble. Where current surveys detect a handful of candidates per year, Roman will detect hundreds, possibly thousands. It will detect objects as small as Mars. We will finally have a proper census of the galaxy's dark population. Not a dozen uncertain signals, but thousands of confirmed worlds. Scheduled for launch in late 2026, Roman will begin transforming this field within its first few years of operation. The questions we have been asking with incomplete data: how many rogue planets are there? What is their size distribution? How do they compare to theory? Will finally have real answers. But those answers will raise a deeper question, one that no telescope has yet answered and that no census can resolve on its own. The question is not how many rogue planets there are. The question is what is inside them, whether their dark interiors are truly dead. Whether the permanent night of interstellar space is as lifeless as it looks from the outside. That is where we are going next, down inside. Let us go inside one, not in imagination, not in metaphor, but as precisely as the science currently allows. Let us descend into a rogue planet that is roughly the size of Earth, that was ejected from its solar system perhaps 1 billion years ago, and that has been drifting through interstellar space ever since. The surface temperature of a rogue planet that has been drifting in interstellar space for 1 billion years would be somewhere around minus 220 degrees Celsius, colder than Pluto. At that temperature, gases that we think of as permanently atmospheric, nitrogen, carbon dioxide, even methane, would have frozen out of the air entirely and settled onto the surface as solid ice. The atmosphere has collapsed onto the ground, and yet the interior tells a completely different story. Deep inside a rocky planet, any rocky planet, whether it orbits a star or not, there is heat. Two kinds. The first is the leftover warmth of formation. When a planet forms from billions of collisions and compressions over tens of millions of years, the kinetic energy converts into heat. 4.5 billion years after its formation, Earth's interior is still hot. The outer core still liquid iron, the mantle still convecting. A rogue planet ejected 1 billion years ago would still have a warm interior. The second heat source is radioactive decay. Uranium, thorium, potassium-40. Naturally radioactive elements that decay slowly over billions of years, releasing energy as they go. On Earth, radioactive decay contributes roughly half of the total heat flowing outward from the interior. A rogue planet has this too. Every rocky planet does. The darkness of interstellar space cannot turn off the radioactive heat buried in a planet's core. Now add a third possibility, one that physicist David Stevenson of Caltech first described in a landmark 1999 paper that remains one of the most quietly extraordinary theoretical results in planetary science. Stevenson realized that if a rogue planet retained a thick atmosphere of molecular hydrogen, something counterintuitive would happen. At high pressures, the hydrogen molecules collide frequently enough to briefly form temporary pairs, and these pairs can absorb infrared radiation, the wavelength through which heat escapes from a planet into space. In other words, at sufficient atmospheric pressure, hydrogen becomes a greenhouse gas. A thick hydrogen atmosphere on a rogue planet would trap the heat rising from the planet's interior, the way a blanket traps body heat. Enough that the surface temperature beneath that blanket could be above 0 Celsius, above the melting point of water, on a planet with no star, in the permanent dark of interstellar space. A rogue planet with a thick hydrogen atmosphere and sufficient internal heat could have liquid water on its surface, an ocean. Beneath a sky so thick with hydrogen that no starlight penetrates, a permanent, absolute night, but warm enough and wet enough to be technically habitable. Stevenson estimated that perhaps 1 in every few thousand Earth-like rogue planets might retain enough hydrogen to produce this effect. But if there are hundreds of billions of rogue planets in the Milky Way, then even a 1 in several thousand probability produces millions of rogue planets with liquid surface water. Millions of dark, invisible worlds drifting through the permanent night between stars with oceans. And that is before we consider what lies beneath the ice on a rogue planet that does not quite have enough internal heat for a surface ocean. The subsurface ocean model is in some ways even more plausible. Consider Europa, frozen on its surface, yet harboring a liquid saltwater ocean beneath its ice, kept liquid by tidal friction from Jupiter's gravity. A rogue planet that carries moons with it into interstellar space, as JWST observations from 2025 suggest many do, would generate the same tidal heating. Those moons, still orbiting, still gravitationally interacting, would keep producing heat through friction. Dark, invisible, drifting through the galaxy, but with liquid water hidden under frozen surfaces, kept warm by the gravity of a starless world. In November 2025, researchers at Ludwig Maximilian University published simulations showing that a moon orbiting a rogue planet with tidal heating from its parent planet could maintain liquid water on its surface for up to 4.3 billion years. 4.3 billion years is the age of life on Earth. Not a brief window of habitability, evolutionary timescales. Time enough for life not just to arise, but to become complex. The inside of a rogue planet, then, is not the frozen wasteland it appears from outside. A frozen surface. Beneath it, a deep ice shell. Beneath that, potentially, liquid water. And beneath the ocean, a rocky seafloor, possibly with hydrothermal vents, the same geological structures that line the floors of Earth's deep oceans. The same structures that some scientists believe were the cradle of life on our planet 4 billion years ago. The darkness outside means nothing to what happens at a hydrothermal vent 3 kilometers below the surface of a liquid water ocean on a rogue planet. The chemistry does not know it is in interstellar space. The heat does not know there is no sun overhead. The molecules simply do what molecules do. They interact. They react. They combine and break apart and combine again over and over, driven by the energy of the vent in the dark over geological time. And sometimes, given the right conditions, molecules that interact in the dark over geological time, driven by chemical energy, eventually produce something that is no longer just chemistry. That last sentence is where the science ends and the question begins. We do not know if life exists on rogue planets. We have no direct evidence. We have no sample. What we have are the conditions, the physics and the chemistry that tell us life is not impossible there. And in the search for life in the universe, not impossible is a different thing from impossible. It is the beginning of a serious question rather than the end of a futile one. Start with the basics. A liquid solvent, almost certainly water, a source of energy for metabolism. Chemical building blocks, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. The elements that make up every living thing on Earth. Time. And a stable environment that remains habitable long enough for life to emerge and persist. Water is available on rogue planets under the right conditions. The chemical building blocks are not specific to star systems. They are the most abundant elements in the universe, present wherever planets form. Energy is the harder question. On Earth, most life derives its energy from the sun, but not all. At hydrothermal vents on the ocean floor, entire ecosystems exist in complete darkness, powered entirely by chemical energy. Organisms that eat rocks, deriving energy from reactions between inorganic compounds. Tube worms, crabs, shrimp, fish, a full ecological community thriving in permanent darkness, fueled entirely by the heat and chemistry of the Earth's interior. No sunlight required, no photosynthesis anywhere in the chain. If this kind of life is possible in Earth's deep ocean, separated from sunlight by 3 kilometers of water, then it is at least plausible on a rogue planet whose hydrothermal vents have been active for 1 billion years in the dark between stars. There is one argument for rogue planet life that rarely gets discussed. A planet that has been ejected from its solar system does not experience the violent bombardment that characterized the early solar system. It does not get hit by giant asteroids every 100 million years. It does not have its surface sterilized repeatedly. It drifts alone, in a region of space where the density of objects is extremely low, hit by almost nothing. A rogue planet's subsurface ocean, once established, might be extraordinarily stable, undisturbed for billions of years, with no mass extinctions, no impact winters, no catastrophic resets. If life emerged there, it might have had time to do things that life on Earth, repeatedly interrupted by catastrophe, never had the chance to do. Now, what we can say, what the science genuinely supports, is this. If life exists in the universe beyond Earth, there is no particular reason it should be confined to planets orbiting stars. The conditions that life requires are not unique to solar systems. They exist, or could exist, in the permanent dark of interstellar space, on worlds that have been alone since almost the beginning. And if the universe is generous with life, if the emergence of living chemistry from non-living chemistry is something that happens wherever the right conditions persist for long enough, then the galaxy may be inhabited in places we never thought to look. Not just around stars, not just on the lit, warm, sunlit worlds we have been cataloguing for decades, but in the dark between them, on the worlds no one can see. Most astronomical discoveries are clean. A star is a star. A galaxy is a galaxy. The measurements are precise. The conclusions are definite. Rogue planets are different. They live at the edge of what we can know. And sometimes, in science as in life, the most interesting questions are the ones that live at edges. On October 19th, 2017, a telescope on the summit of Haleakala volcano in Hawaii found something that did not belong. A moving object, faint, traveling at an unusual speed. And as astronomers around the world scrambled to point their telescopes at it before it disappeared, they began to realize that whatever it was, it had not come from anywhere in our solar system. It was moving too fast, on a trajectory too hyperbolic, too sharply curved around the sun and outbound to have originated here. Its speed relative to the sun exceeded the escape velocity of the solar system. It had not been orbiting the sun before it arrived. It came from somewhere else, from interstellar space. It was the first interstellar object ever detected passing through our solar system. The team named it Oumuamua, a Hawaiian word meaning roughly a messenger from afar arriving first. The name turned out to be more appropriate than anyone could have anticipated. What Oumuamua looked like exactly, nobody is certain. The data showed an object that varied dramatically in brightness as it rotated, suggesting it was extremely elongated, perhaps 10 times longer than it was wide, tumbling end over end through space. Nothing in our solar system has that shape. And then it did something that nobody expected. As it moved away from the sun, it accelerated, not dramatically, but measurably, in a way that gravity alone could not explain. Something was pushing it. Astronomers looked for the outgassing that would explain this in a comet. There was nothing. No coma, no detectable gas, and yet it accelerated. As of 2026, there is no scientific consensus on what Oumuamua was. Every explanation resolves some of the mystery and leaves other pieces unexplained. It is long gone now, receding into interstellar space at tens of kilometers per second, completely unobservable, carrying its secrets with it forever. 2 years later, in August 2019, a second interstellar object was detected, Comet 2 E/Borisov. This one was less mysterious. It behaved like a comet. It had a coma. It outgassed. It confirmed the same fundamental truth. Interstellar objects pass through our solar system. They come from other stars, move through our neighborhood briefly, and continue on their way. Astronomers estimate that at any given moment, within the orbit of Neptune alone, there may be around 10,000 Oumuamua-sized interstellar objects passing through. Invisible to our current telescopes because they are too faint to detect unless they pass very close to the sun. An interstellar object like Oumuamua passes through the inner solar system approximately once per year. We detected the first one in 2017 only because our telescopes had finally become sensitive enough. Now, ask a larger question. If small interstellar fragments pass through our solar system constantly, how often does something larger come through? Over the 4.5 billion year history of our solar system, the probability that a rogue planet has passed through the outer regions, through the Oort cloud, through the distant reaches beyond Neptune, is not negligible. It may have happened multiple times. And if it did, we might still be able to see the evidence. In 2023, the researchers proposed that the peculiar orbital architecture of some distant trans-Neptunian objects, orbits tilted and clustered in ways that do not fit simple models, could be the gravitational fingerprint of a rogue planet that passed through our outer solar system hundreds of millions of years ago. Not a permanent resident, something that came through and left, a gravitational ghost. The rogue planet is gone, long gone, continuing its journey through the galaxy. But the orbits it disturbed remain as a record, written in the paths of distant icy bodies, waiting for someone to learn to read them. We may have been touched by a rogue planet. We may be living with the evidence of that encounter right now, in the strange tilted orbits of objects at the edge of our solar system, without quite being able to prove it. We think of our solar system as closed, self-contained. 8 planets, 1 star, a family of worlds that formed together and has orbited together ever since. But the solar system is not closed. It has always been permeable. Interstellar objects have always passed through it. Stars have passed close to it. And perhaps once or twice in 4.5 billion years, a rogue planet, a world that belonged to another star before belonging to no one, came close enough to leave its mark. There is a hypothesis in planetary science that has been debated, modeled, criticized, refined and disputed since 2016. It goes by a simple name, Planet 9. The hypothesis begins with a pattern. In the outer solar system, beyond Neptune, a handful of the most distant icy bodies have orbits that seem to cluster. Their orbital planes are tilted in similar ways. Their elongated paths are oriented in similar directions in space. In 2016, astronomers Mike Brown and Konstantin Batygin at Caltech published a paper arguing that the most natural explanation for this clustering was a 9th planet, massive, distant, on an elongated orbit far beyond Neptune, whose gravity was gently herding those distant bodies into their aligned configuration over billions of years. They estimated its mass at 5 to 10 Earth masses. Its orbit would take it between 400 and 800 astronomical units from the Sun at closest approach. At that distance, extraordinarily faint, but there, waiting. Since 2016, the search for Planet 9 has been one of the most active programs in observational astronomy. Multiple surveys have scanned the sky. None have found it. That does not rule it out. The sky is large, and Planet 9, if it exists, may currently be near the far end of its orbit where it is faintest. But the absence of detection has led researchers to propose alternatives. In 2023, one of those alternatives entered the conversation in a form that connects directly to everything we have discussed tonight. A team proposed that the TNO orbital clustering could be explained not by a permanent 9th planet in orbit around the Sun, but by a rogue planet that passed through the outer solar system sometime in the past. A massive world, not gravitationally bound to the Sun, that moved through on a hyperbolic trajectory, sweeping through the region where the distant bodies orbit, and gravitationally disturbing them, and then continuing outward and away. The rogue planet is gone, but the gravitational imprint of its passage remains, written in the orbital tilts of dozens of distant icy bodies. What looks like evidence of a permanent Planet 9 might actually be a ghost. The echo of a visitor that came through billions of years ago and left. In 2024, a separate paper pushed further, using refined models of the gravitational interaction between a passing rogue planet and the outer solar system. Researchers showed there is room for up to 5 Earth-sized rogue planets in the current outer solar system. objects possibly captured from interstellar space into very distant, loosely bound orbits around the Sun during a close stellar encounter early in solar system history. At distances of hundreds or thousands of astronomical units, invisible to current surveys. But possibly there, our solar system might have adopted orphans from interstellar space. The Vera C. Rubin Observatory in Chile, designed to survey the southern sky with extraordinary depth and speed across a decade-long legacy survey of space and time, will dramatically improve our knowledge of the distant outer solar system. As it accumulates data, it will detect thousands of new trans-Neptunian objects. With a larger and more complete sample, the statistical question of whether the clustering is real and what is causing it should become much clearer. If there is a Planet 9 in a permanent orbit, Rubin should either find it or constrain its position enough for a direct targeted search. If the clustering is a rogue planet's gravitational ghost rather than a permanent resident, that too should become apparent. Either answer changes how we think about our solar system. A permanent Planet 9 would be a fundamental member of our solar family that we missed entirely for the first century of systematic planetary astronomy. A rogue planet gravitational ghost would mean our solar system has been shaped by the galaxy around it in ways we are only beginning to understand. And it would mean that somewhere out there in the galaxy is the rogue planet that visited us, still traveling, still dark, carrying the memory of its brief encounter with our sun in the invisible paths it carved through space as it passed. We do not know its name. We do not know where it is now. We only know or suspect from the orbital tilts of distant icy bodies that it was here once, in the neighborhood of our sun, among the worlds we call home, and then it left, the way rogue planets always do, silently, into the dark. We have traveled a long way tonight. We started in a dark room, each watching a candle flicker as something invisible passed in front of it. We have been to the cause of ejecting solar systems, watching young planets get hurled into interstellar space in the first violent million years of their existence. We have descended inside a rogue planet, down through the frozen surface and the deep ice and the dark liquid ocean to the hydrothermal vents on the seafloor, where chemistry happens in the permanent dark, whether anyone is watching or not. We have looked at the question of life, not answered it because it cannot be answered yet, but looked at it honestly and found it harder to dismiss than the conventional picture of the universe might suggest. We have met Oumuamua. We have considered the possibility that our own solar system bears the orbital fingerprints of a rogue planet encounter. And we have looked at the horizon, at what is coming. What is coming is a revolution. The Nancy Grace Roman Space Telescope, and launching in late 2026 will transform rogue planet science the way Hubble transformed our understanding of the deep universe. Its galactic bulge time domain survey will detect microlensing events at a rate 1,000 times greater than any ground-based survey. Within a few years of operation, we will have a proper census. We will know how many rogue planets there are. We will know their mass distribution, whether Earth mass rogues are common or rare. We will know whether the theoretical predictions from planetary ejection models match the real population. And Roman will find the small ones, objects as small as Mars, the class of worlds where liquid water and internal heat and subsurface oceans are most plausible. The worlds where the life question is most pressing. Alongside Roman, the Rubin Observatory's decade-long survey is accumulating a movie of the southern sky. When it encounters an interstellar object passing through the solar system, and statistically, in 10 years of full sky surveying, it almost certainly will. We will have days or weeks of warning rather than the frantic few weeks we had with Oumuamua. If the next visitor is large enough, we may have time to point the James Webb Space Telescope at it, take spectra of its surface composition, and read the chemistry of another solar system in the light bouncing off a fragment that crossed the galaxy to come to us. We do not know what rogue planets carry, what their interiors hold, whether their oceans are inhabited or sterile. We have one confirmed rogue planet with a measured mass, KMT 2024BLG0792, 10,000 light-years away, 22% of Jupiter's mass, measured for the first time on January 1st, 2026. We have statistical evidence for hundreds of billions more. We have theory and physics and models that tell us the conditions for life exist in interstellar space. And we have telescopes being built and launched right now that will, within a decade, transform our knowledge from a handful of ghost signals to a proper census of the galaxy's hidden population. The universe is stranger than it looks on a clear night. When you step outside and look up, you see stars, thousands visible to the naked eye, billions more behind them. You see light. You see the known, mapped, catalogued universe. But between every star you can see, and between the stars you cannot, and between the galaxies beyond them, in the permanent darkness that makes up most of the volume of everything that exists, there are worlds. Dark, cold, silent, alone. Rolling through the galaxy on trajectories set billions of years ago by the chaos of their births. Some of them, almost certainly, with oceans. Some of those oceans, possibly, with something moving through the water. We have barely begun to look for them. We have detected one with enough precision to call it confirmed. We have a telescope launching this year that will find hundreds more. We are at the very beginning of learning what the dark between the stars actually contains. And what it contains might be more than we ever imagined. The galaxy is not empty space punctuated by stars. It is a vast, dark ocean filled with wandering worlds, and we are just now learning to see in the dark. Sleep well tonight. But before you close your eyes, look out at the sky one more time. Somewhere out there, past what you can see, past what any telescope currently pointed at that patch of sky can detect, something is moving. A world without a star. Dark, silent, ancient, alone. Carrying the history of another sun. And it has been moving since before the Earth existed.